Let us explore how to sketch graph of a polynomial function. We have an example here, and we'll try to sketch graph of f of x equals to x plus 4 times x plus 2 whole square times x minus 1 to the power of 4. Now, before sketching this graph, let's look into some characteristics of this polynomial function. Well, I'll recommend you to go through a couple of videos, since to cover this topic as a whole, we need to look into different aspects, which I am trying to cover in 3 or 4 videos. Well, some of them which are most important are given here. So first thing which is most important is to understand that a polynomial function has a domain of real numbers. So it extends from minus infinity to plus infinity with a continuous smooth curve without any cusp or corners or breaks, correct? So first thing which we understand about a polynomial function is that its domain d of x is equals to all real numbers, right? So there are no breaks in between. So when you try to sketch the graph of a polynomial, try to sketch as smooth as possible without any breaks. Now the second important thing which you should know is the end behavior. Now end behavior is actually determined by two things. What are those? Well, one is degree of the polynomial, right? And the other is leading coefficient, right? These two things decide behavior of the polynomial, right? Leading coefficient. These are the two things. Now, what is the degree of this function? It is 4 plus 2, 6 plus 1, 7. So degree is 7, or we can say it's an odd degree polynomial. And the leading coefficient is, when you multiply these terms, x times x squared times x to the power of 4, you are going to get x to the power of 7, and the coefficient is plus 1. So the important thing is the leading coefficient is positive. So if leading coefficient is positive and the degree is 7, what is going to be the end behavior? Well, let's try to sketch it here. So what we have here is, that's the coordinate plane. So we have x-axis and y-axis. The end behavior should be what? Degree is 7, odd degree. Leading coefficient positive. Positive means right side up, right? So that is positive. Odd degree means opposite ends. So it's kind of starting from this side. So it is going from quadrant 3 to quadrant 1. So that is how this polynomial is going to be. Now, of course, when it goes like that, it will cross x-axis at a couple of points, and those are called the x-intercepts. So let's figure out where are the x-intercepts. Easy to find. Since at x-intercepts, f of x should be 0, and it can be 0 when each factor is 0, 1 by 1, right? So let's calculate. X plus 4 is 0 when? When x is equals to minus 4, right? How about x plus 2? It will be 0 at minus 2, and x minus 1 will be 0 at plus 1. So we have 3 x-intercepts. So let's place these 3 x-intercepts on the coordinate plane. So we have, let us say this is 4 for us. Okay, minus 4, I mean. Minus 2 is kind of half the value, minus 2. And 1, let us say this is 1 for us, correct? So these are the positions for our x-intercepts, which are minus 4, minus 2, and 1. Now let's look into zeros. Okay, purposely I am taking zeros separately. Many of our students think that zeros and x-intercepts are kind of same thing. Now take this video also as a review of characteristics of polynomials, because since characteristics is key to sketching the polynomial itself. How are zeros different from x-intercepts? Well, the zeros have order and x-intercepts do not have any order. zeros decide the behavior of the graph of polynomial at the x-intercept. I'll show you how. The first factor, x plus 1, is linear. We say the order, let me write the word order here, right? Purposely, we are using a different ink, and I'm highlighting order as 1 since it is linear. This one, the order is 2, kind of a parabola, quadratic, right? So the order is 2 here because of the degree 2, and x minus 1 to the power of 4, this 0 has an order of 4. It really means there are 4 zeros there. There are 4 zeros at x minus 1, 2 0 at minus 2, and 1 at minus 4. This is a very important aspect to understand. So, and as I said, zeros decide the behavior of the graph. So at minus 4, the order is 1. It acts like a linear graph. So it crosses this line like a line, crosses x-axis like a line. Do you see that part? It crosses like that. Now at minus 2, we have a 0 of order 2, so it will not cross, it will bounce back, kind of like this. Do you see that? Bouncing back like a vertex of a parabola. And at 1, the order is 4. It will again bounce back. But this time it will be more flatter. That's the whole reason. I've purposely taken degrees of 2 and 4 to show you that when you sketch a polynomial, if the degrees are like different, you can actually show them by how flat they are at the x-intercepts. Do you see that part? So that is how zeros play a very big role in sketching a polynomial. Correct? I think we got all of it. Well, we can add one more aspect to it here, and that is y-intercept. Y-intercept is when x is equals to 0, right? Or I should say f of 0 is y-intercept, which is equals to how much? So if I substitute 0 for x, I get 4 times 2 square times minus 1 to the power of 4. So basically I get 4 times 2 square times minus 1 to the power of 4, and that gives me minus 1 to the power of 4 is positive. So we have 4 times 4 is 8 positive. So the y-intercept is 8. Now these values are good enough for us to sketch a graph of polynomial. So you get all the points here and y-intercept of 8. So wherever my graph crosses y-axis, I'll mark that as 8. Well, that is kind of tricky, right? So what I will do now here is connect my points with a smooth graph. So what I'll do, I know is going to cross like this, so the behavior is kind of like this. Do you see that? So that shows that my graph starts from minus infinity, is kind of like this, starting from quadrant 3. Then it has to turn back, right? So that I could connect these two. So it will turn back like this and go like this. So that line kind of, I'm trying to make it smooth. Okay. And then we have to connect these, correct? So we have just go like this and connect them, and then in one stroke we can draw our graph like this. That is the polynomial. So finally, with this smooth curve, we get the sketch of polynomial function given to us. Now it crosses y-axis at a point, and this should be what? This should be 8, right? So let me just write 8 here. So we have x-axis here, f of x on the y-axis, and that is a smooth curve starting from quadrant 3 and then moving along into quadrant 1 from minus infinity to plus infinity. Do you see that? So that is how we can sketch a graph of a polynomial function. So important aspects here are that once we know the degree and the leading coefficient, we know it starts where and ends where. It starts in quadrant 3, ends in quadrant 1. And then we have to analyze the zeros, right? So all the zeros and their order determine behavior of the function at the x-intercept. And then we get to connect them with a smooth curve to get the result. I hope that makes things very simple and easy to understand. I hope you appreciate it. You can subscribe to my videos and look into more videos on similar kind. Thank you and all the best.